1971 280 SE. This supposedly is a very rare beast. And what else makes this very rare, it only has 3,700 miles on it. Yes, 3,700 miles. If you could just hear and feel how this door opens. I mean, I don't even have to push it that much. That is locked. This door is so solid. It's incredible. It is so, the detents work barely any wear on the detents on the door or anything like that. Look at this, Zerk fittings. Back in the days, I remember when I was young, we used to grease these on hinges. So there's the mileage, and no, this has not been tampered with. 3,700 miles. The bare air conditioning unit. Everything they're trying to keep original on this. It was in an accident, and which is really a shame. 280, 3.5. This thing is just in immaculate condition if you look down the side there. And about a year ago, I was called in to do the recovery on this, and it was smashed right here. I think they had to do that inner frame pillar inside there. Look at the original type battery, other than it's an interstate. But the repair on this vehicle probably cost more than a brand new Mercedes-Benz. They even wanted to keep, even though the hoses were a little pushed and everything like that, they kept the original style hoses. It looks like they were able to locate where money was no object, a new accumulator, switch, original hoses. Look at this, look at these old valves here. Look how this valving, the king valves, set up that you don't see anymore. The original hoses. The condition of these hoses is immaculate. Let's see if I could zoom in on this. The old cloth woven hoses. Something we won't see very many times in our life again. Now, unfortunately, not the original old compressor. I do have the original compressor, and I didn't rebuild it. I was thinking of rebuilding it. I just don't have the time. When I was a kid with my father, I used to rebuild compressors, and probably for my first 5 or 10 years, the old A6s, Yorks, Tecumsehs and stuff, but it just became not worth it. The cost of labor here in the San Francisco, California area is just so high. And then you have competitors who are always hiring the cheapest guy they could get off the street to do things at minimum wage. You just can't, you just stop. I mean, I stopped making hoses. I stopped rebuilding compressors. You get them from China and Taiwan so cheap, or from, you know, Brazil, or from whatever country they rebuild them, Mexico. They tried to rebuild them here in United States, usually Texas, right on the border in Mexico, with the cheapest labor. Came in, the failure rate and the defect rate was just so high right out of the box. It's ridiculous, but still I wouldn't compete with them. I just stopped rebuilding. So maybe someday for this vehicle, I put the compressor away somewhere. It was hitting the front shaft. The front plate was moved and distorted a little bit where something hit the plate a little. I might do a video sometime within the next year if I ever clear my old rebuilding burns out, and I'll rebuild an old Frigidaire A6 compressor all the way down to the shim plates and everything like that. Totally disassemble it, measure everything, put it all back together, evacuate it, pressure test it, and it'll be sitting in a box. And who knows, maybe it'll go back on this vehicle. They wanted to keep the original, even though it's not efficient. just for the looks, they wanted to keep the original condenser. So it has that very wide, like 12 fins in 1 inch spacing with the very large 3/8 tubes. Very inefficient, not efficient at all. I mean, that would, for me, this would be the first thing I would replace, but they want to keep the original looks, bolts, nuts, everything. I mean, all the way down to the original bolts after the paint job and everything like that. This goes into show. It actually has to have the original bolt markings on everything. So this is a very meticulous situation here. I'm going to be keeping a vacuum pump probably all day while I go off to other jobs. I'll throw a vacuum pump on here and I'll be pumping this thing, trying to dry it out as much as possible. I'll be doing a triple purge with nitrogen. I know it has a new dryer on it, and I'll do above and beyond the Call of Duty to make sure this has no problems, if at all possible. And maybe still use R12 in that one too. This one will go over to R134. It has a new compressor on it, and it says R134 on it, and it has the new dryer. Anytime you do one of these new dryers, always do new switches. Do not reuse the old new switches. Automatically dryer, new switches. No ifs, ands, or buts. Don't try to do anything but. What's that? Where? I don't know what the address of this place is. I'm not sure. It's, are you looking for what business? What's the name of the business you're looking for? Oh. That I don't know. And so this one's going to get 134. I'm about to break over my other vacuum pump over here to complete this down. I'm going to do a pressure test on this one. And see you in a little while after when I charge these back up. And as you see, this is Mercedes as they progressed. If you look at the size of these tubes, it's the same configuration. It's kind of a semi-serpentine parallel because it has 2 sets of tubes, one in the front, one in the back. They're serpentine, semi, multi-pass, but it's smaller tubes. These are 6mm compared to this old style that was 3/8 of an inch. You'll see that there's more of them. They're tighter. You'll see if you look at my fingers as a comparison between my fingers, if you count how many fins there are, then you come over here and you count how many fins there are, and within like a given inch, these are tighter packed. The more fins, the better. The smaller the tubes, the better. The more tubes, the better. It's all about surface area and mass, and to dissipate heat. You want more surface area, you want more mass on the outside, you want more fins per inch, and you don't want straight fins. You want fins with deformities in them. And often they'll make them with a little wobble in them, or they'll actually imprint them and they'll actually break up the fin, and they'll put little fins within the fins. They'll do some breakup because you don't want the airflow to go straight through the fins. You want to force it with some disturbance inside of them, so it forces the air in a not straight path. So it gives more pressure as it goes through and makes a break, and it makes eddies, and it goes through, and it makes more surface area as you go through instead of a straight pass. And that gives more time for the air to pick up heat from the fin, and the fin is press fit to the copper tube that is on side there. So it's all about time and surface area, weight, mass, and the type of material it's made out of. Copper is better than aluminum. If we could use silver, that would be great, because even silver is much better heat conductor than even copper. But who can afford? That would be like a $4,000 or $5,000 condenser if you can make them out of silver. And no, gold is not better than silver. Gold is better at being an antioxidant, anti-corrosive, but it's not better at heat conduction. And silver is better at electrical conduction too. Physics. All right, that's it. Let me get out of here. This is getting too long. We're approaching 10 minutes. See you guys on the next video.